Well, today we're going to be looking on how to solve exponential equations. And exponential equations just mean any equation where the variable is in the exponent. So we'll be looking at that. Now, that is a little bit of a review. We have done problems similar to that, like 4 to the x equals 8. And typically how we would solve that is we would get the same base. So 4 is 2 squared, so we get 2x. And then 8 is 2 to the third, and once we have that, we can show that the exponents are equal, and we would just solve for x. X equals 3 over 2. And that works for some problems, but actually that's a quite rare problem. That doesn't happen very often. So if we look at a problem like we have right now, we have 4 to the x plus 1 equals 20. We're not going to be able to get the same base on that, so we need a different strategy on how to solve that. So basically what we're going to do is we're going to change this problem. Instead of writing it as a power, the opposite of that would be writing it as a log. So since our power is base 4, we're going to have a log base 4 of 20. And remember, logs equal the exponent, and our exponent is x plus 1. And since we're just trying to solve for x, we want x all by itself. We want to get rid of this plus 1. It really doesn't matter what's on the other side. So to get rid of that plus 1, we just need to subtract it on both sides, and then we'll have x all by itself. So that's negative 1 plus log base 4 of 20 equals x, and we are finished. So again, the key of these ones is just to remember that the opposite of writing something as a power is to write it as a log, and we'll do that on the next example also. So on number 2, on this one, we want to get, again, we're going to do PEMDAS backwards. So we're going to do, add, subtract first, multiply and divide, and so forth. So on this one, the first thing we're going to do is subtract 3 from both sides of the equal sign, and then it really just becomes just like the previous problem. So when we subtract those, they get 9. We won't be able to rewrite these with the same base, so we're going to have to, the 5 and the 9, so we're going to have to rewrite the power as a log. So again, that's log base 5 of 9 equals 2x plus 1. And again, we're focusing on the side that with an x, we want to get x all by itself. So again, we're going to subtract 1 from both sides, so we get negative 1 plus log 5 of 9 equals 2. We could rewrite that problem log of 5 base 9 minus 1 equals 2, but that looks a little confusing. That looks like an 8. So it's technically correct, but we're not going to write it that way, just to write it a little bit more of a clear way of writing that. Oops, and I forgot the x there. And then finally, so again, we want to solve for x, so get x by itself, and we divide both sides by 2, and we are done. X is all by itself. It doesn't look like it's finished, but this is an exact answer. If we wanted to write that as a decimal, we could. It would just have to put all of it in our calculators. But as an exact answer, we have it right there. All right, so moving on to number 3. Over here, again, we're trying to solve for x. So we want to get rid of the 7 and the 2 first. We're doing PEMDAS backwards. So first thing, again, is subtract 7 from both sides. So 2e to the 3x plus 4 equals 1. And so again, if we're doing PEMDAS backwards, multiply, divide, add, and subtract. We did the add and subtract first. Next, we got to get rid of any multiplication. So we got to get rid of 2 times this. So to get rid of the 2 times e, we're going to divide both sides by that. And then we have e to the 3x plus 4, right? 2 over 2 is 1. And then the final thing is now, all right, we want to get x by itself. We want to get rid of this power. To get rid of the power, we're going to rewrite that as a log. So we could write log base e, but remember, we don't do that. We write ln of 1/2 equals the exponent. And the exponent is 3x plus 4. Logs find exponents. And then from there, we're just focusing in on we want to solve for x. So the first thing, again, is subtract 4. We do that from both sides of the equation. And then we have 3 times x. We don't want 3 times x. We want to get rid of that times 3, so we divide both sides by 3. All right, and for our last example, very similar. Oops, sorry, it skipped a little bit. So for our last example that we'll do is this one, number 4. So again, we're doing PEMDAS backwards. So the first thing we would do is subtract 5. And we get 2 to the x plus 1 equals negative 1. And then to get x by itself, we could rewrite this as a log. But we need to stop and just think about this problem right here. So 2 to what power plus 1 equals negative 1. And we've talked about this before. Powers are always positive. A power will never equal a negative number. So once we see that this is negative or 0, that's not a possible solution. So you're going to put no solution on this problem. There is no number that we can put for x that we can put up there. So no number we can put up for x that this will equal negative 1.